So we built a next generation cloud native storage subsystem. And that's what basically powers Neon and powers Postgres. So with that, now that we have that storage, we can do pretty cool things. And we are focusing a lot on the developer experience. So now if you think about kind of the new lines of code written every day around the world, pretty much the majority of those lines of code are written in JavaScript. So we'll look at the JavaScript developer and we want to make sure that it's incredibly straightforward, incredibly easy, incredibly intuitive to consume and use Postgres, and something that a lot of people know and love, and certainly people in this audience know what this is. We learned that developer experience, if you build for it, can be a foundational architectural choice, right? Or an architectural driver. And here I'm quoting a tweet from Matteo Collina. Maybe some people know who that is. And what he's saying is, something recently clicked. Developer experience is a part of a software architecture. Now, I have been building databases for probably 17 years. So it's been a long time. I worked on a company called Microsoft on a product called SQL Server. Then, yeah, some people know what SQL Server is. You run my code. So, well, I worked on CLR integration, runtime, which everybody uses, scalability, and XML. Nobody uses XML anymore. But XML kind of technology became JSON, which is still warms my heart. And we're learning, so infrastructure people know when you need to change the architecture of an infrastructure project, and databases are certainly an infrastructure project, that actually means that there's an opportunity to rethink and rewrite the whole thing. And when people are tweeting like this and assuming they're right, and building for developer experience impacts the architecture, that opens up new possibilities. And Neon is certainly striving to seize one of those opportunities. I want to deconstruct what makes a good Devx. And frankly, I learned what makes a good Devx from the companies that are focused on front end, and the companies like Vercel, Netlify, Prisma, obviously GitHub, Replit, Fly.io is kind of the new kid on the block, which we're huge fans of. So those companies are rebuilding dev platforms for the next generation developer experience. So we systems people learn from them. And let me try to deconstruct it real quick. So what makes a good Devx? And if you guys disagree, throw some tomatoes at me or make new suggestions of what else makes a good developer experience. Well, it's certainly CLIs, APIs, and docs. It's latency of like, I want this thing and this thing is there, right? Setting up your developer environment, provisioning infrastructure. You kind of want to live in the world where you click and it's there. And I'm going to give you a pretty visceral example. You know how like you go, who loves going on the AWS console? Okay, I see. Yeah, some people love going on the AWS console, but not many, right? And then, if you consume their stuff through an API, the way the API is set up is like, oh, I want this resource. They're like, oh, here's a token. Hold that token and then come back to me and ask me, am I done or not? And then you just kind of wait. But of course, a much nicer developer experience when everything is synchronous, right? And you can make it synchronous when it's fast, right? And if you can say, oh, I need, in our case, Postgres, in 2 seconds you get Postgres. The other thing that kind of the anti-pattern of developer experience is cold starts. Cold starts is like a big subject, and solving cold starts is very, very domain specific. What else gives good developer experience? We all like REST and GraphQL. Why? Well, because we can call it from a JavaScript, right? And like I said, lots of code is written in JavaScript these days. We all code in developer environments, right? Sometimes it takes a long time to set up your laptop. Now, people work on something, they want to share their developer environment with somebody else. And then there's all these dependencies that you have from your developer environments. So having something that's really packageable, that's good developer experience. If it's not packageable, it's bad developer experience. Everybody runs CI/CD. And now these modern platforms, like Vercel, Netlify, Fly, they implement this thing called push to deploy, right? You do git push, this thing is up there on GitHub, those platforms pick it up from there, and the app is up and running in production. So all of those things are good. And we as database people are looking at that and it's like, well, if we want to run Postgres, like half of those things are just not true. And that's why we thought that there is an opportunity to redefine what a Postgres experience might be, and that's why we built Neon. This is another tweet, and this tweet is from Jake, who is the founder of Railway.app. Maybe some people know what Railway is. For those who don't, it's kind of like a next generation Heroku. And he's claiming that front end will always have a good developer experience because the speed of iteration is high. And then infrastructure is not going to have, it's always going to be lagging behind because the speed of iteration is slow. And in a way that's true. And as a database engineer, we used to say database wars are battles on the water in slow motion. Like it's slow, right? You build in systems code, your release cycle is like a year. I remember at SQL Server, some people are users, release cycle was 5 years, which is kind of in the modern day and age is completely nuts. Like that doesn't make any sense. And I'm telling him that we're going to have it great for Neon. And now I'll explain how Neon works, what Neon architecture is. We also have a blog post on neon.tech. So if you click on the blog, as well as go and start our GitHub repo. Everything at Neon is open source. And we'll talk about how we build for developer experience. And also we'll explain how we build for engineering velocity. How can we be faster, advancing the technology faster than people next to us. So when you use Postgres, if you decided to do it yourself, or if you use something like RDS or DigitalOcean Postgres or whatever, typically you end up having something like this, right? You're going to have a primary instance of Postgres in the cloud running on the VM. That VM is going to have an EBS volume attached to this VM for storage, and that's a durable storage. And then you realize that this VM can go away, and you will have downtime, so you'll have another one with another network attached storage, and then you replicate Postgres between the two, either synchronously or asynchronously. And then you realize that if one fails, then you don't have any redundancy, so you'll have another one. So you have 3, right? And EBS volumes also provide a level of redundancy for you. So now you're paying for storage at least 6 times. EBS volumes are not known to be cheap, and also they're not really known to be fast unless you pay Amazon even more money for the 6 times the storage plus more money for provision IOPS. The other thing is that if you look at this infrastructure picture, that you'll notice that you will either over-provision storage or compute. Right? Postgres is a monolith, and it has storage and compute put together. The amount of storage and compute is the amount of storage and compute on the VM. And then in day 0, when you don't have any data in your database, you clearly over-provision storage. And then as you run out of storage, you have a no shit moment. Sorry for using those words in the presentation that live streamed. And you'll have to do something, right? So you can do a lot better. And the way to do better requires some system engineering. We built all that next generation storage, which is going to be right here in the page servers and safekeepers part in Rust. And we built it in Rust because we are optimizing for engineering velocity. And we want, and we observed it, and I've been part of large C and C++ projects before, that engineering velocity is a lot, can be a lot higher in Rust. So how this works? So Postgres storage engine operates at what is called page level, and pages are 8 kilobyte blobs of bytes. And right there, when Postgres reads data, down in the code, it goes and at some point requests a page, reads a page from disk. So we go and modify that part of the Postgres engine. And by the way, all the Postgres modifications are in our repo, in the Neon database repo. And we are optimistic that we're going to make it into Postgres 16 or 17. Postgres 15, that ship has sailed. And so we replace reading that page from disk to an RPC call in our service, into the page servers. And that service is multi-tenant and scalable, right? So we run it kind of one per region. Then the right path of Postgres is, you do update T, set value, or like name equals Nikita. And then all the way down, Postgres generates a log record, a transaction log record, which looks kind of like this, a pointer to the page and a diff, like in bytes, of what kind of changes you want to apply to that page. There are lots of other types of log records, but that's like a typical one. So we intercept that right path as well, and instead of saving, applying that log record locally, we're sending that log record into our service called Safekeepers. And it's also a multi-tenant service that's built one per region for all the clients. It's scalable. The performance, the workload is very predictable, right? We're just kind of sending log records, and all we need to do is persist them. So we've implemented a consensus algorithm to make it very reliable. And both page servers and Safekeepers talk to S3, so we can offload that data to S3, and especially cold data, right? And S3 compared to the live low latency storage is basically 100 times cheaper. So, we can give you infinite storage for your Postgres instances. So lots of benefits into this architecture. A few that I will highlight. The biggest one is Postgres Compute. If you do that, Postgres Compute is stateless. And that's like your genuine Postgres. It runs all the extensions and just like works like Postgres because it is Postgres. It became stateless. Now we can put it in a container and run it in Kubernetes. And now we can dynamically allocate resources to those containers. We can also kill it, start it on a different machine, and because this is not a monolith anymore, we don't need to move data to that new machine, right? We can just start it on a different machine and then point at the same storage. So that's what allows us to both start Postgres in about 2 seconds and dynamically adjust the amount of resources we allocate to Postgres. So that's kind of the big benefit number one. The second benefit that we have here is, well, we control storage. What other tricks do we can do with storage? And we introduced the notion of branches. So now you can actually create a branch of your Postgres instance. And it's a full copy of data that is, and the creation of the branch takes also like a second or two. So how is that possible? Well, the magic technology is copy and write, right? So we don't really copy that data. We just like move a bunch of pointers around and generate another endpoint. And when you connect to that endpoint and start writing in it, then you diverge in the two branches. So you're only paying the delta overhead on storage. But branches is really cool, right? Because A, you can query them. And if you don't, see, they're all integrated with S3, so they're like offloaded to S3, so they're actually very cheap. So you don't need to like delete them. Two, they're cool because branch could be your backup. So instead of creating a backup and then having a size of data long time restore operation, you can just like basically say, oh, I'm just gonna swap it with this branch. So now that's also instant. And the more important thing is, well, branches could be a part of your workflow. So now every time you deploy schema changes or any changes in your code base that are impacting the database, you can create a database branch and try running your CI/CD pipelines against that branch before you roll them into main. And that is what I'm going to demonstrate to you. We worked with Prisma, and I'm going to demonstrate you how you can run a migration through Prisma that is using the new branching functionality. So this is my console. All these records here are endpoints to serverless Postgres. Just for you here, I can create another one. This is another one. I just created it. So I can go to the SQL editor and type select, just like in the blog post, select hello world. So it's up and running. So I didn't lie to you earlier in the presentation. You can really spin it up in 2 seconds. We can actually take a look how long it took. Yeah, 3 seconds. Sorry, I did lie to you about 2 seconds, but it's 3 seconds. And the other thing is, we completely scale down to 0 if you're not using it. So if you're not using it, you're not paying for it. So, and I'll give you an example. It has a bit of a cold start issue. So it takes the same 2 seconds to bring it back to life on starting to generate traffic on it. So this is what happens when system engineers try to build a blog, a web app. So this is what it looks like. So I'm going to refresh. And then you see that spinning. That is a cold start. Now it's going to start. Yeah, so now we refreshed. I can go back to my console, and you'll see that Prisma Day is active right now, right? So Prisma Day was the special Postgres that I put together for this presentation. The blog runs this kind of blog runs off of this. So now I can go to the blog, create a draft, say Prisma Day, author Nikita, and author name is empty. And I'll put something like, I don't know, rocket ship here. Create. So I've created that draft. Now later I can publish it, but that doesn't really matter. Next day, I realized I want to enforce that non-null names in my blog. So I'm going to run a Prisma migration right now in front of you. So I'm going to do git checkout out -b, not null, I don't know, 102 or something like this. So I clearly practiced it 101 times. So then I'm going to go to Prisma, schema.prisma. I'm going to find that string name. I'm going to remove the question mark here. And then I'm going to run npx prisma migrate dev not null 102. This will run for a while, I think. Let's see. Now this demo is not like fully. Ooh. Cannot reach the database. Let's just try that again. Cool hats neon.tech. Okay. Well, live debugging. This is Morning Firefly. And no, this is the cool hat database. Okay, it's up. And Prisma Day local. That's live too. Okay, all data will be lost, yes. So the janky part of the demo is that I created I put the database URL and database URL local as just empty databases locally. Later on, as we do a fully integration with Prisma, we'll make it a lot smoother. But anyway, so that generated a bunch of migrations. Well, it hasn't yet, but it's going to very soon. And now I'm going to commit it, and I'm going to create a pull request in GitHub. Hey, hey. All right. I'm running out of time. Okay, git status. Okay, untracked file, I'm going to edit right now. Git add, git commit, -a-m. Prisma, git push. Oh well, set upstream. So I pushed it. Then I go here, and it says create a pull request. I say create a pull request. And now, so this is kind of cool, right? We have Vercel, we have Prisma, and we have GitHub Actions. When you click on GitHub Actions, it's running. It created a branch. It's right here. I'm trying to make it bigger. It switched to a branch, and it's trying to apply migrations to the branch. And all your production database is not like, it's not suffering, right? It keeps running your blog. You can continue interfacing with the blog. And it says, well, you know, the migration failed. And what I'm highlighting here is column name and relation user contains null values. So now you're safely ran your CI/CD pipeline against the production database. Well, you create a branch, right? And it failed in the middle. But you know that everything is okay, right? Because you didn't touch your production database. So now you can go back here to Prisma Day, go to the SQL editor, update names in the table users and say it's V for Vendetta or something, and rerun the jobs. And this will now succeed. So that is an example of how you can integrate branching all the way into CI/CD pipelines. And now that what allows you to scale that application process to more people because your deployments are now safer. We're working on those integrations with Soren at Prisma. We're working on those integrations with Vercel. We're working on those integrations with Netlify. We're super excited to give everybody, every developer, a push button Postgres. And because everything is open source, we're also excited about the fact that the internet is going to be running on open source technology rather than proprietary technology, let's say Amazon Aurora or RDS, that is, you know, for you it's Postgres, but like all this machinery underneath is proprietary. All our machinery is open source. So take a look, start us on GitHub, and also know that we are hiring. And we're particularly hiring front-end, back-end system engineers and DevRels. And we're always welcome more engineers to come in and join us. Thank you.